to day 31 of calculus. Today we're going to talk about mins and maxes. So first we'll find two non-negative numbers x and y whose sum is 20 and a few other things. So first we're saying that the sum is 20. So x plus y is equal to 20. So we're trying, and they're two non-negative numbers, so x has to be greater than 0 and y has to be greater than 0. And we're trying to make their product as large as possible. Well, their product would be, we'll call it z, the product, or you can say p, whatever you want, is x times y. And we want to make that as large as possible, so we know we want to take a derivative and set that derivative equal to 0 like we've done many times in the past. But this has too many variables. X, y is two variables, we want it down to 1. But what do we know from what we've written above here? Well, y is equal to 20 minus x. So we can plug that in right there. So z, our product, I chose z, you could choose p again, is x times 20 minus x. So our product is 20x minus x squared. We take our derivative and we end up with 20 minus 2x. And as we've done many times in the past, we set it equal to 0. Go up here, 0 is equal to 20 minus 2x. So 20 is equal to 2x, so x is equal to 10. So we want to check to make sure that that makes a maximum. So we do a sign diagram, and we have x. So this is the x value being, 10. These are x values, and we know we can't go any smaller than 0. And then we have the z prime right here. So we have two areas right here, a z value, an x value less than 10, but greater than 0, and greater than 10. So you're plugging into the derivative, which is right here. So if you plug in 5, you get a positive number. If you plug in 12, you end up with negative. So you know this is going up and down, so it's going to be a max. So the question is, what are the two numbers? Well, we know y is equal to 20 minus x, and x is equal to 10. So if x is equal to 10, then y also equals 10. So that maximizes the product. What about if x squared y is as large as possible? So we're going to do something very similar. We once again know that x plus y is equal to 20. So y is equal to 20 minus x. But what are we trying to maximize this time? Well, we're trying to maximize x squared y. Again, can't differentiate that yet, so let's plug that in right there. So we end up with z is equal to x squared times 20 minus x. So now we need to multiply that out. We end up with z is equal to 20x squared minus x cubed. Same process again. We take the derivative, and this time we get 40x minus 3x squared. We're going to do the same thing again. We set it equal to 0, so 40x minus 3x squared. Let's factor out an x, so we get x times 40 minus 3x. Yep, 40 minus 3x. So in this case, we have two things multiplied together to get 0, this and that. So we know x is equal to 0, or 40 minus 3x. 40 minus 3x is equal to 0. In this case, it would be 40 equals 3x. So x is equal to 40 over 3. Well, if x is 0, this would be 0. So we're not going to use that. So when we do out this, we have our values of 0. We have 40 over 3. And then you have three regions. To the left of 0, which you can't do because it has to be positive, between 0 and 40 over 3, and to the right. And when you do that, you're doing the checking with the derivative, which is right here. And when you do the sign diagram, you figure that it's negative, and then it's positive, and then it's negative for the z prime. So what does that say? It's going, the function's going up and down, so there's a max that's occurring when x is equal to 40 over 3. So if we want to find the y value, we know that y is equal to 20 minus x. So when x is equal to 40 over 3, y is equal to 20 minus 40 over 3, which is 60 over 3 minus 40 over 3, which is equal to 20 over 3. So that would be your y value right there. So we're going to do something similar and just build and use a different equation. We're trying to make this as big as possible. We still know that x plus y is equal to 20. So we know that y is equal to 20 minus x. That's carrying over from our original statement. So now we plug this y value into the y value there. So we are trying to make this as big as possible. We're trying to make z as big as possible. So z is equal to 2x cubed plus, and then we have 20 minus x squared. And when you do this out, you get this line, and then you're going to have to simplify it a little more and try to get it as one polynomial, which I did by combining like terms and writing things in descending order. And now I take the derivative. Same process as before. You end up with 6x squared plus 2x minus 40. And we set this equal to 0 like we've done before, and this is where we hope it's nicely factorable. We can factor out a 2 at least. So 0 is equal to 2 times 3x squared plus x minus 20. So you really hope that this is nicely factorable. It's not. You need to use the quadratic formula. And when you use the quadratic formula, you end up with x is equaling 2.42 or negative 2.75. But you know x has to be greater than 0, so you can't use this one. So now we need to make sure we do a sign diagram. So we have 2.42 right here. We also know it has to be greater than 0. And x plus y has to be less than 20. Sorry, it has to be 20. So what's the biggest x could be? X could be all the way up to 20. It's the biggest x can be. So we're doing z prime here. So when you do this, you have 4 areas, right? You have 4 areas. Let's get another color. Let's get the green, the 3 areas right there. So when you do this, you know actually when you plug things into our derivative right here, it's actually going to be negative, 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 and it's positive, 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 positive. The problem with that is that that means that this is a minimum. We're trying to maximize it. We're trying to as large as possible it. So we know 2.42 is a minimum, meaning the maximum is going to occur either here when x is really close to 0 or up here. So we need to actually plug in 0 for x. And does it say greater than 0? I think it just says non-negative. So x could be 0. So these could actually be, sorry, these are both, I just noticed it should be greater than or equal to 0 and y should be greater than or equal to 0. So x could be 0. So we can test these endpoints. We want to know what is the product when x is 0 and when x is 20. So what happens when when you plug in 0? So when you plug in 0 into this equation right here, when you plug in 0, you end up with 400. But when you plug in 20, you end up with, you plug in 20 into this, plug in 20, x is equal to 20. You get 20 to the 3rd power times 2, so it's going to be 16,000. So what's the max? The max is indeed 16,000 here. So it turns out the max happens right here when x is 20. The product is 16,000. One more you could check. You could do z at 2.42, and you would expect it to be lower than both of these. You would expect it to be lower than both of these, here and here. So the max product is 16,000 for this one. The lower left-hand corner of a rectangle is at the point negative 1, 1. So let's just sketch this. So we have negative 1, negative 1. So right here, there's negative 1 right there. There's our corner. Yay. And the uppermost corner is on the parabola negative x squared plus 9. What does negative x squared plus 9 look like? Well, it looks like this. It's facing down like this. So that right there is y equals negative x squared plus 9. So it's saying one corner is right here, and the other corner is on that parabola. So what does this look like? Well, let's say that was right here. You would end up with a rectangle that kind of looks like this. All the way over like that. There's your rectangle right there. Excellent. And at this point can move. It can move down it, it can move up it. Oh, and x is between 2 and 3. So we know it has to be between 2 and, where's 3? 3 is actually right here. So we know x has to be between here. So it can move all the way to here, and it can move all the way to here. Okay, what are the dimensions of the rectangle whose area is the greatest? So this point right here is negative 1, negative 1. So we need a function that models the area. Well, this is a rectangle, so you know area is equal to base times height. Base times height. Okay, so this point right here, we don't know what that point is, so let's call it xy. Let's call it xy. And remember, the x is going to be this distance right here. X is the distance from the right of the y-axis. And where is the y value? The y value is right here, the height. So what is the base? The base is this distance right here. So that's going to be the green plus this distance, which is 1. You go back one, that distance is 1. So in this case, the area is equal to x plus 1 times y plus 1. It's y plus 1 because it's this distance plus this little more, which is 1. And it's x plus 1 because it's this distance plus that distance, which is x plus 1. So now, though, we need a relationship between x and y because we can't differentiate this too many variables. But we know y is equal to negative x squared plus 9. So what does that tell us? A is equal to x plus 1 times what's y? Negative x squared plus 9 plus 1. All we've done is we've plugged in this equation right here for y. Okay, so now we multiply it out. You get this nice polynomial written with powers descending, and then you do the derivative. Negative 3x squared minus 2x plus 10. You'd hope it's nicely factorable. It's not really nicely factorable. And when you use the quadratic equation, you end up with x is equal to 2 plus or minus the square root of 124 all over negative 6. So you make the sign diagram, and what you find out, remember these are the x values and these are the a prime values. Are they positive or negative? It's going negative, and then it's positive, and then it's negative. So what does that tell you? The function is decreasing, increasing, and decreasing. So there is where a max occurs. There is where a max occurs. And that matches what we wanted because that needed to be between 3 and 2, as stated by the problem. So what you need to then do is you take that x value and you plug it into the, it says, I think, what is the dimensions of the rectangle whose area is the greatest? You take that x value, about 1.52, and you plug it into here. So y is equal to negative 1.52 squared plus 9. And you end up with 6.69. So that's the x and y coordinates, but it's asking for the dimensions of the rectangle. Remember, you have to add in this 1 and 1 on each side. So the final dimensions would be adding 1 to the x and y values. So you end up with 2.52 by 7.69. That would be the final dimensions. Because the x and y coordinates just give you this. You need to add on that little bit, and you need to add on this little bit.